Orbital welding and automated welding processes. Hello folks, welcome to today's lesson on orbital welding and automated welding processes. In this lecture, we will explore the fundamentals of orbital welding, delve into various automated welding processes and equipment, discuss advanced welding techniques, and address safety considerations. This comprehensive overview is designed for individuals engaged in industries where precision and efficiency in welding are crucial. Orbital welding process fundamentals. Understanding orbital welding. The fundamentals of orbital welding. Orbital welding is a specialized form of welding that involves rotating the electrode around the workpiece in a continuous orbit. This process is particularly useful for welding pipes or tubes where access is limited and precision is essential. The welding torch moves in a circular motion around a stationary object, ensuring an even weld. Key features of orbital welding include precision, ensures consistent quality and eliminates human error. Repeatability, ideal for mass production and high-precision industries. Time efficiency, reduces welding time without compromising quality. Components of an orbital welding system. Orbital welding systems comprise several key components. Power supply provides the necessary energy for welding. Welding head houses the welding electrode and rotates it around the workpiece. Control unit manages the welding parameters and monitors the process. Applications of orbital welding. Orbital welding is used in various industries, including aerospace for high-strength and lightweight structures, pharmaceuticals for sanitary piping systems, oil and gas for pipelines and offshore installations, automated welding processes and equipment. Overview of automated welding. Automated welding involves the use of mechanized and robotic systems to perform welding tasks. These systems improve productivity, ensure repeatability, and maintain consistent weld quality. Types of automated welding processes. Robotic welding utilizes programmable robots to perform welding tasks suitable for repetitive and intricate welds. Mechanized welding involves machinery assistance to control the welding process, often used in semi-automated operations. Automatic welding, fully automated processes with minimal human intervention, ideal for mass production. Equipment used in automated welding. Automated welding employs a range of equipment. Welding robots, flexible and precise, capable of handling complex tasks. Positioners and manipulators support and move workpieces for optimal welding positions. Sensors and cameras monitor the welding process and ensure quality control. Advanced welding techniques and safety. Hybrid welding. Hybrid welding combines different welding processes to capitalize on their individual strengths. For example, laser GMAW gas metal arc welding offers deep penetration from the laser and excellent deposition from the arc. Friction stir welding. Friction stir welding FSW is a solid-state joining process ideal for non-ferrous metals and alloys. A rotating tool generates frictional heat, softening the material and enabling seamless joining without melting. Laser welding. Laser welding utilizes a concentrated light beam for high-precision welding. Its applications are found in electronics, automotive, and medical device manufacturing. Electron beam welding. Electron beam welding (EBW) uses a focused beam of electrons to join materials in a vacuum. It offers deep penetration and strong welds suitable for aerospace and nuclear industries. Narrow groove welding. Narrow groove welding is designed for thick materials, reducing filler material usage and improving efficiency. It's commonly applied in constructing large vessels and pressure equipment. Safety in automated and orbital welding. Importance of safety in welding. Safety is paramount in welding due to inherent hazards such as high temperatures, fumes, and optical radiation. Following proper safety protocols minimizes risks and ensures a safe working environment. Key safety measures. Personal protective equipment (PPE) includes helmets, gloves, and protective clothing to guard against burns and UV exposure. Fume extraction systems, essential for removing harmful fumes and ensuring clean air quality. Proper ventilation ensures adequate airflow to remove hazardous particles and gases. Regular inspections, regularly checking equipment and systems for potential hazards. Training and certification. Welders must be well-trained and certified to handle specialized equipment safely. Continuous education on advancements and safety practices is crucial. Emergency procedures. Establish clear emergency procedures and conduct regular drills to prepare for potential incidents, ensuring employee safety and minimizing disruptions. Executive summary. Here's a summary of orbital welding and automated welding processes. Orbital welding. 1. Definition: orbital welding is a welding process that uses a rotating welding head to weld pipes and tubes in a single pass. 2. Key features: orbital welding provides high-quality welds, increased productivity, and reduced labor costs. 3. Applications: orbital welding is commonly used in industries such as aerospace, automotive, and pharmaceuticals. 4. Benefits: orbital welding provides consistent and reliable welds, reduces the risk of human error, and increases efficiency. Automated welding processes. 1. Definition: automated welding processes use robots or machines to perform welding tasks, reducing the need for human intervention. 2. Types of automated welding. Common types of automated welding include robotic welding, automated submerged arc welding, and automated gas metal arc welding. 3. Key features: automated welding processes provide increased productivity, improved weld quality, and reduced labor costs. 4. Applications: automated welding is commonly used in industries such as automotive, aerospace, and construction. 5. Benefits: automated welding provides consistent and reliable welds, reduces the risk of human error, and increases efficiency. Advantages of orbital and automated welding. 1. Increased productivity. Orbital and automated welding processes can significantly increase productivity and reduce production time. 2. Improved weld quality. Orbital and automated welding processes provide consistent and reliable welds, reducing the risk of defects and imperfections. 3. Reduced labor costs. Orbital and automated welding processes reduce the need for human labor, resulting in cost savings and improved efficiency. 4. Enhanced safety. Orbital and automated welding processes reduce the risk of injury and exposure to hazardous materials. Challenges and limitations. 1. High initial investment. Orbital and automated welding processes require a significant initial investment in equipment and training. 2. Limited flexibility. Orbital and automated welding processes may not be suitable for complex or variable welding tasks. 3. Maintenance and repair. Orbital and automated welding equipment requires regular maintenance and repair to ensure optimal performance. 4. Operator training. Operators require specialized training to operate and maintain orbital and automated welding equipment. Here's a summary of orbital welding process fundamentals. Orbital welding process fundamentals. 1. Definition: orbital welding is a welding process that uses a rotating welding head to weld pipes and tubes in a single pass. Key components. 1. Welding head. The welding head is the rotating component that holds the electrode and shielding gas. 2. Electrode. The electrode is the consumable wire that is fed into the weld pool. 3. Shielding gas. The shielding gas protects the weld pool from atmospheric gases. 4. Control system. The control system regulates the welding parameters such as current, voltage, and travel speed. Welding parameters. 1. Current. The current controls the heat input and weld penetration. 2. Voltage. The voltage controls the arc length and stability. 3. Travel speed. The travel speed controls the weld speed and quality. 4. Shielding gas flow rate. The shielding gas flow rate controls the protection of the weld pool. Orbital welding techniques. 1. Autogenous welding. Autogenous welding uses the heat generated by the arc to melt the base metal. 2. Shielded metal arc welding SMAW. SMAW uses a consumable electrode covered in flux to protect the weld pool. 3. Gas metal arc welding GMAW. GMAW uses a continuous wire electrode and shielding gas to protect the weld pool. 4. Gas tungsten arc welding GTAW. GTAW uses a non-consumable tungsten electrode and shielding gas to protect the weld pool. Advantages of orbital welding. 1. High-quality welds. Orbital welding produces high-quality welds with minimal defects. 2. Increased productivity. Orbital welding increases productivity by reducing the number of weld passes required. 3. Improved safety. Orbital welding improves safety by reducing the risk of injury from hot sparks and molten metal. Limitations of orbital welding. 1. Equipment cost. Orbital welding equipment is expensive and requires a significant investment. 2. Operator training. Orbital welding requires specialized training and expertise. 3. Limited flexibility. Orbital welding is limited to welding pipes and tubes in a single pass. Here's a summary of applications of orbital welding. Applications of orbital welding. 1. Oil and gas industry. Orbital welding is used for welding pipelines, process piping, and other equipment in the oil and gas industry. 2. Power generation. Orbital welding is used for welding boiler tubes, heat exchangers, and other equipment in power generation plants. 3. Chemical processing. Orbital welding is used for welding process piping, reactors, and other equipment in chemical processing plants. 4. Pharmaceutical industry. Orbital welding is used for welding process piping, tanks, and other equipment in pharmaceutical plants. 5. Food and beverage industry. Orbital welding is used for welding process piping, tanks, and other equipment in food and beverage plants. 6. Aerospace industry. Orbital welding is used for welding aircraft and spacecraft components such as fuel lines, hydraulic lines, and other tubing. 7. Automotive industry. Orbital welding is used for welding fuel lines, brake lines, and other tubing in the automotive industry. 8. Medical equipment. Orbital welding is used for welding medical equipment such as hospital equipment, medical devices, and implants. 9. Semiconductor industry. Orbital welding is used for welding process piping, tanks, and other equipment in semiconductor manufacturing plants. Benefits of orbital welding in various industries. 1. Improved quality. Orbital welding provides high-quality welds with minimal defects. 2. Increased productivity. Orbital welding increases productivity by reducing the number of weld passes required. 3. Improved safety. Orbital welding improves safety by reducing the risk of injury from hot sparks and molten metal. 4. Reduced costs. Orbital welding reduces costs by minimizing material waste and reducing the need for repairs. Future trends in orbital welding. 1. Increased use of automation. Increased use of automation in orbital welding to improve productivity and quality. 2. Development of new welding processes. Development of new welding processes such as laser orbital welding to improve quality and productivity. 3. Increased use of robotics. Increased use of robotics in orbital welding to improve productivity and quality. 4. Development of new materials. Development of new materials, such as advanced alloys, to improve the performance of orbital welding. Here's a summary of advanced welding techniques and safety. Advanced welding techniques. 1. Laser beam welding LBW. Uses a high-energy laser beam to melt and join metals. 2. Electron beam welding EBW. Uses a focused beam of electrons to melt and join metals. 3. Friction stir welding FSW. Uses a rotating tool to generate heat and join metals. 4. Ultrasonic welding USW. uses high-frequency vibrations to generate heat and join metals. 5. Robotic welding uses robots to automate the welding process, improving productivity and quality. Advanced safety technologies. 1. Welding helmets with auto-darkening filters provide improved eye protection and reduce the risk of eye injuries. 2. Welding robots with safety features, equipped with safety features such as collision detection and emergency stop buttons. 3. Advanced ventilation systems provide improved ventilation and reduce the risk of inhalation of welding fumes and gases. 4. Smart welding equipment equipped with advanced sensors and monitoring systems to improve safety and quality. Best practices for advanced welding techniques and safety. 1. Proper training. Welders must receive proper training on advanced welding techniques and safety procedures. 2. Regular maintenance. Welding equipment must be regularly maintained to ensure proper function and safety. 3. Quality control. Welds must be inspected and tested to ensure quality and safety. 4. Continuous improvement. Welding processes and safety procedures must be continuously improved to ensure optimal safety and quality. Conclusion. In this lesson, we have covered the essential aspects of orbital and automated welding processes. From understanding the fundamentals of orbital welding to exploring automated welding techniques and emphasizing safety, this knowledge is vital for achieving excellence in industrial applications. By implementing these practices, you can enhance productivity, ensure quality, and maintain a safe working environment. Happy welding and learning! See you again in the next lesson.